everybody. Welcome to Studio 64. My name's David, and I've been searching the interzones for more science, space, and tech news to share with you. And I came across this at Ride Apart. This should be very interesting. Yes, NASA's new super alloy could transform everything. This should be very, very interesting indeed. Yes, the high heat alloy is said to last 2,500 times longer than other nickel based alloys. Yeah, I'm not a scientist myself, but I love all science, and any sort of engineering, chemical engineering, manufacturing, aerospace, astronomy, astrology. Love the astrology, dear oh dear. Astrophysics, love the whole lot. Marine biology, you name it. I'm just a fan of science and a student of all sciences. So if anybody out there is a metallologist, see, I can't even say what it is, but if you're into this sort of thing, please, like a chemist or something like that, please feel free to comment down below because we'd love to get your input. It'd be fantastic. Thank you. Now, we often see and hear manufacturers say they've used aerospace grade materials in their products. And while a lot of these companies simply use the term as a buzzword, there are quite a few that actually make use of these high quality, high resistance materials designed for the industry for enhanced performance and longevity. I think I need some of that myself, actually. Or is that, what is that other thing that people like me would use? What is it called? Not Viagra. Coffee. That's it. Yeah. Coffee. That's the other thing we use for enhanced performance and longevity. Good old cup of the old Joe. Yeah, that's the one. Yeah, nothing like it. Oh, dear Lord. Where did I get Viagra from? All right, indeed, a lot of the high quality alloys and composites we interact with on a regular basis first started life in aerospace applications, and NASA's been working non stop to push the boundaries of materials science even further. In fact, it just licensed a new super alloy called GRX810, and it could hold the key to future of high performance machinery, even basic stuff, like Velcro and the uh, what is that? They're using tungsten now and all this sort of thing in fusion reactors and things, and the you know all that sort of stuff that came from the space program. I always had to laugh though that NASA spent was it NASA that spent millions of dollars trying to figure out to get a pen to work in space, because when the astronauts were writing things up like this, the ink would run down, the pens would run out, and somebody eventually, after millions of dollars of research and development, suggested they use a pencil. Well, that was funny. Oh God, you've got to have a laugh, haven't you? So, what makes GRX 810 so special? Well, maybe later. Thank you. Well, for starters, it is a 3D printable material, so it can be molded and shaped into pretty much any component. Furthermore, it is said to be a high temperature material, which makes it more durable and lightweight than existing alloys used in aeroplane and spacecraft parts. Really interesting. I was having a discussion with a friend of mine the other day, and we were saying how Star Trek um, sort of predicted a lot of things, such as the flip phone, which was called the communicator back in the day, the original Star Trek TV series. They also, when Next Generation came along in the 80s, they had the replicators, so they could literally make stuff out of nothing at all. And we have the opinion, this friend of mine and I have this opinion, that 3D printers are very, very, very primitive Star Trek replicators. You can literally take a material that's absolutely nothing and turn it into something spectacular, like printing an entire house. I've seen 3D printers making houses. I've seen them make, little toys. And then again, I've seen them make car parts, and we all know about the guns they make and all that sort of stuff. So again, the technology is not inherently evil; it's what you do with it. If you get my point. But yeah, that's really, really interesting. So 3D printing of this stuff looks fantastic. Now, according to them, it could revolutionize manufacturing, including the power sports industry. Yeah, now look at this. So there's an example of how NASA's GRX 810 super alloy can transform life as we know it. It can actually make a component like this. That's absolutely incredible. Now, whether you 3D print it as individual parts and put it together, or it prints it like this, that remains to be seen. I'm assuming it would print it as individual parts at this stage with the technology. But wow, can you imagine having the ability to 3D print with this new NASA material a component like that? Can you imagine driving your car across a desert or something? Oh my God, I've just dropped a ball joint, or my tire's blown, or I've lost the generator or something. How about we print another one? You download the manufacturing specs from the specs from the manufacturer and a design, plug it into your computer and 3D print one. People go, that's ridiculous. I said, well, no, not really. I mean, look at the stuff we're doing now. It's just a step ahead of that. Look into the future. Don't let your minds be limited. I mean, I can remember back in the day my father saying you could never, computers are these big things that take over entire rooms. You can never take one up to the top of a mountain because they could never make them portable enough. Now we carry them around in our bloody pocket. We might as well be cyborgs. They're stapled to people's hands. So always look to the future and expand your mind and see the possibilities, the potential of these things. Also, the downfall, just like AI. Good tool, you control it, don't let it control you. Yeah. Yes, aeroplane and spacecraft parts. You read that right. That means the GRX 810 just has to be among the strongest, lightest, and most reliable alloys for it to be used in some of the highest risk applications known to man. Airbus and Boeing, take note, please. More specifically, GRX 810 is envisioned to aid in developing better liquid rocket engine injectors, combustors, turbines, and hot section components. These parts can reach temperatures in excess of 2,000 degrees Fahrenheit, a fifth of the temperature of the surface of the sun. Wow, that's pretty incredible. Now, Dr. Tim Smith, co-inventor of GRX 810 and a materials researcher at NASA Glenn, explained how the new alloy is a groundbreaking feat of technology. GRX 810 represents a new alloy design, space, and manufacturing technique that was impossible just a few years ago. Yeah, the acceleration in technology is absolutely incredible. Like what used to take 20 years now takes 2. I mean, an example again, I've said this in previous videos, is AI. The difference between AI 3.5 and ChatGPT, 3.5 and ChatGPT 4 is literally decades ahead, right? I mean, if you compared it to another piece of technology, and yet it's only been a few years. I mean, even you're looking at ChatGPT, and it came on that you ask it how long it's been around, and it says like 4 years or something, like ChatGPT 3.5. I mean, it's just insane. I mean, you're talking a few years here, you're not talking decades, and this is, said impossible just a few years ago. Now, what's it going to be like in just 5 years? Not 50 years, but just 5 years. It's fascinating how quickly we're progressing. Smith, alongside his colleague Christopher Kansos, invented GRX 810 using cutting-edge computer modeling and laser 3D printing that fuses various metals together in a layer-by-layer construction. Tiny particles containing oxygen atoms were spread throughout the alloy to enhance its strength. Now, as a result, when compared to other nickel-based alloys, NASA says that GRX 810 can endure higher stress and temperatures and can last a whopping 2,500 times longer. Even better still, is up to 4 times better at flexing before breaking, twice as resistant to damage from oxidization. I can't wait for this to be perfected, right? So it lasts 2,500 times longer. It's 4 times better at flexing before breaking and twice as resistant from damage from oxidization, which, I'm not being a materials scientist, I'm assuming oxidization means rust or corrosion, right? So wait till it's 40 times better at flexing before breaking, and wait till it's 20 times better to be resistant from rust or corrosion, right? And this is going to be what, 25,000 times it's going to last longer. 25,000, 25,000 times longer. That's unbelievable. And that's just at this stage of the game. That's what people can't envision. Something comes out as like a prototype, you could say, And people go, well, that's crap. I can't use that. I said, use your vision. You look forward. This is just the start. You know, it's like when everyone makes a prototype of something, guarantee when it's made in the garage that, the inventor's mum has helped him somewhere by stitching together a cover for it from his old duck pajamas when he was 9, But once you get hold of more research and development, more money, more manufacturing, then people want it. I find that fascinating that people can't see the potential of things. As of the moment, GRX 810 has been licensed for production by 4 American companies consisting of Carpenter Technology Corporation of Reading, Pennsylvania, Elementum 3D Incorporated of, is that Erie, Colorado? Sorry if I've mispronounced that to the people of Erie. Lind Advanced Material Technologies Incorporated of Indianapolis, and Powder Alloy Corporation of Loveland, Ohio. Yes, I love this bit here. Now, I know what some of you are probably thinking. What are we doing rambling on about aerospace grade alloys on a power sports website? Well, aerospace grade materials can be found pretty much in everything that has to do with power sports, from the carbon fiber in your helmets and vehicle bodywork to the metals and alloys found inside your vehicle's engines. This is the point that I was making. People can't see what use this thing could be. Now you know. You're getting a hint of what it could be, done. As I said before, print a vehicle part. Can you imagine being on your bike, riding your bike, all of a sudden something breaks? Well, what are you going to do? Get a tow truck, take it home, wait for the part to turn up? No, you can print one straight away and fit it yourself if you're mechanically inclined. Or ring up a mechanic, a roadside mechanic, and have him turn up to your broken down bike by the side of the road, and you'll go, oh, I'm sorry you've broken this, mate. Well, I've just printed another one. Could you please fit this for me? So you can see where the future is going. Absolutely amazing. Now, what we're getting at here is the potential a super alloy that the GRX10 has, not just for mankind's outer space exploration initiatives, but even for the simplest stuff. A lot of materials we encounter on a daily basis started life in the aerospace industry. Today's high performance cars, bikes, and power sport vehicles are already pretty damn cutting edge. I mean, nobody really needs a 300 horsepower motorcycle. But seeing the potential a super alloy like GRX 810 holds could result in some pretty crazy innovations if and when, and more likely when, it becomes commercially available. Yeah. Can you imagine that sort of material, as they said back up here? A GRX 810 can endure higher stress and temperatures. It can last a whopping 2,500 times longer, 4 times better at flexing before breaking, and twice as resistant to damage from oxidization. Can you imagine that in a Formula One car? That would be awesome. What about the super bikes for those into motorcycles? Unbelievable. Absolutely amazing. Now, we could very well be seeing much smaller, more compact engines and motors producing insane amounts of power and torque. That's not unusual either. Back in the day, my first car was a 186 cubic inch straight six, right? A 2.9 litre when you convert it. A 179 cubic inch, sorry, a 2.9 litre, 186, if I do the mental calculations right, was a 3 litre. Straight six. You can now get a 3 litre V6, and it has the same equivalent of a V8 back in the day, like a 253 cubic inch or something like that, a 4.2 litre V8. Even the 4-cylinder could do it, probably. It's quite fascinating. Yes, we could very well see seeing much smaller, more compact engines and motors producing insane amounts of torque. And because these components last much longer and more resistant to wear, these machines can be much more reliable and efficient too, with lower overall weights, less reciprocating mass, and much longer service intervals. Manufacturers are all about achieving the impossible, ultra-high performance mated with reliability and efficiency. Perhaps the super alloy like GRX 810 is the key to this. Yeah, got to agree. It's fascinating. Very, very much looking forward to this becoming something that can be used in everyday life for ordinary people like us. You know what I mean? So, your cars, your bikes, imagine having to, Elon Musk could use it for his rockets, for God's sake, right? You could buy your push bikes, can be made of the stuff, make them lighter and stronger and more efficient and everything else. It should be very, very interesting to see where this goes. Absolutely and utterly fascinating. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
my brain hurts!